We had question 2, which said that if there were 2.4-meter long parallel wires that are separated by 3 meters, and each wire had a 28 amplitude current, we're determining the resultant force, both magnitude and direction, on both of the wires. For part A, if they were in opposite directions, and part 2, if they were in the same direction. So first, with the opposite direction, we use the right hand rule with the thumb and curving your hand around to determine if the field went into or out of the board. In opposite directions, they both came into the board for the internal direction. So then we used the second right hand rule to determine the direction of the force by using the direction of the current, the opposite field, and that determined that our forces for both of them went out, so they had a repelling force. To find the magnitude, we used this equation and this equation, and we ended up putting them together to solve for the force, getting 2.09 times 10 to the negative 5th newtons. And for part B, all of the information was the same, so the only difference was we used the first right-hand rule to determine the direction of the field again, and as you can see, one went into the board and one came out of the board. So when we used the second right-hand rule to determine the direction of the forces, they both ended up going in, so we had an attractive force between the two. We used the same equations, and since we had the same numbers, it should have ended up being the same, and it did. And that is how we solved for the same direction and different direction currents.